So the next area, what are the activities needed for software? And in our analogy, what are the activities needed for a house? Well, you don't just start building if you want a house, and for software you shouldn't just start coding. You think about what the requirements are. What's your plans going to be? How big is the house? How many bathrooms? How many rooms? How many toilets? How many kitchens? And some of the quality components as well. If it's a luxury flat being built, it may need a different sort of finish to the bathroom than if it's a ordinary family house. How expensive are the kitchen units? Top of the range granite worktops, or is it just basic functional? Then you can start thinking about estimating and cost. You can base this on your previous experience, or you can use metrics like the number of bedrooms, the square foot being produced. And across the building trade, if if you're producing a fairly standard family house with brick walls and a slate roof, then for this size it's going to be about this much. But also the quality expectations come into it as well. Do you want the top of the range kitchen unit with the granite worktops, or is it just a more ordinary kitchen? And that'll affect the cost. And the construction process, is it brick walls or is it some fancy oak timber frame barn conversion you're doing? So you have to think about those to get anywhere near a decent cost estimation. There has to be some sequence, some planning. What's done first, what's done when, and some control mechanisms for that as well, to make sure that things are completed on time to the right level of quality. Often external checks, like building regulations for a house, they come and check that the wall's the right thickness and the plumbing works and so on. So put that into the software arena. What are the analogies? Well, here's some of the activities that are discussed in the course materials. First is around requirements. Requirements analysis. What are you trying to achieve? How are you going to achieve that? Key examples here, context diagrams, which are the ins and outs of software. What's the boundary of the system? In a house example, that's where's the driveway, how many cars need to be parked, how many doors you're going to have, where's the electricity and plumbing coming in and out, and so on. And then in software, it's the data flow diagrams. What data is going to flow between what sort of systems, what sort of screens would the user see, where's the data stored, and so on. And that's roughly comparable to the idea of a plan of the house, how many bedrooms, how many bathrooms. And again, those quality expectations that we talked about for bedrooms and bathrooms and kitchens also come into play for computer systems. Is this a fairly standard set of data representing a name and address, for example? Fairly easy. Or is it something more complex that has a higher threshold of needing to be customised to your business? Therefore, you might need to allow an extra cost for that. Because that's the next stage, is estimation. Once you have some idea of the requirements, typically cost estimates are based upon requirements rather than dreamt up. So you can think about how long, how much, how you're going to do this. And again, some of those requirements metrics can be used. So you can look at things like function point analysis. You can look at how many screens there are to be used, how many data stores, what elements of data are being stored, and use those to derive estimates of cost, time, team size, the things that you need to do. You can also base this on previous experience, like with a house builder. Always good in an organisation to keep a track of what your estimates for a project were and what it turned out to be in the end, so you can see how close your estimates are. You can approach people who know these things well. It's a Delphi method. You can sample a number of experts to say how long is this going to take. A number of ways of estimating. Then some detailed design. How you structure this. How are you going to make sure that you get the quality that you want to achieve in your software? Where are the checkpoints for that? How is that going to be measured? What processes are you going to use? And the work breakdown and scheduling. What has to be done first? What's done afterwards? How do they fit together? How long is it going to take? When you need the right sort of expertise in your project. A plug here for the M882 project management course from the Open University. Good project management structure. Then some building. Actually build it. A lot of work typically around testing. Both, does it meet the functional design, and then acceptance testing, do the users think it meets the requirements that they set? And you need to think about maintenance and evolution and quality control of all the processes within this so that you can make the software actually usable. And the point to make here is that your cost estimation needs to cover all of these things, not just the coding area, for example. So you need to include testing, documentation, training, and so on. So, next stage is thinking about processes. What are the different processes for building a house, let's say? Here's some examples. Different sorts of skills needed to do these. To build a wall or build a roof versus put your plumbing in. Different skills. There's some implied sequence. You need to do some things first, some things afterwards. You need to build the walls first before you put the roof on, for example. So here's a software process known as the waterfall mechanism, one of the standard sequential approaches. It's sequential, you do one thing after another, you do it in sequence, you do requirements gathering, then you do design, then you do implementation, and so on. Waterfall model, you can see it looks a bit like water flowing down a waterfall. Has some advantages, it's structured, it's well understood, there's processes designed around these, lots of software development tools that fit this sort of model. Has some disadvantages, it expects that you know all the requirements up front. It's about having a structure, having a plan. Next example is another sequential one, this is the V model, which is based around the waterfall model, so coming down the left hand side is the waterfall steps, and then matching it to the right hand side are the testing steps. So for the actual coding stage, there's unit testing, does it actually meet the requirements of that particular module? And there's integration testing, do the modules fit together and do the sort of functions that are required? There's overall functional system testing, does it meet the requirements? And overall acceptance testing, does it meet what the users actually want? Are they able to use it? So it's an adaptation of the waterfall model. Next example is an iterative one. This is bone spiral model talked about in the course materials. Starts off here, iterative means you go around and around, or you do things again and again. So here we're talking about the cycle of requirements, analysis, development and test and implementation. You iterate around that loop a number of times, typically with some prototypes. In the example shown here, there's 2 prototypes before the release of the software. Some advantages here is people get to see what's being developed. They may be able to suggest improvements on the basis of prototypes. They may say, oh, that's not what I meant this. But they don't know until they see it. Some disadvantages, you may not get everything you want in the first release. You may have to wait for subsequent releases to get the things that you need. So some advantages, some disadvantages. And here's a more generic model of the iterative process, where you have some initial planning, you go around through that loop of requirements, analysis, design, implementation, deploy something, but then you carry on through to testing, evaluation, does it really meet what you need, loop back around more development to the second release, and so on. So typically you'll find software has multiple releases. Another software process model is the architecture-driven or model-driven. And here's an example of one architectural style. There's several mentioned in section 8.5 of the book, course materials. This is model view controller. It's one of those fundamental software patterns that exist that have been identified, where there's some data, there's something controlling this, and there's different views and there's different interactions between those components. So there's a number of architectural styles which you say, well, this fits model view controller or one of the other analogies. Let's build according to that structure. Next example of a software process is the agile process. Key point for me here is the time scale shown on the diagram. That you may have maybe months between different software releases, but then you're down to days between how you're structuring your activities, down to hours for negotiating, and down to minutes between the difference between programming and test. Typically, programmer sits down with user, does some programming, says, is this what you want? And no, I'd like that button over there, can it do this? What happens when? So very rapid test iteration cycle. Worth commenting again on the Agile Manifesto, which is one of the key documents describing the Agile approach, referenced in the course materials. They say, we value a number of things. We value individuals and interactions over processes and tools. We value working software over comprehensive documentation. We value customer collaboration over contract negotiation. We value responding to change over following a plan. So you can see there's some advantages they see there. They think interaction, working software. Some disadvantages, maybe not comprehensive documentation. Maybe difficult to apply in a contract situation, for example, outsourced. They value responding to change rather than following a plan. Very different from the sequential model, where once you've got your requirements set, there's typically a very rigid change process to accept any changes to that.